Hi everybody, Dan McCoy, R. McCoy. I'm really excited today. We're back at the ACPA booth, but I'm kind of geeking out right now because this is Dr. Tyler Lay, and he has done some very exciting research that affects us in pumping, but not only pumping, but also what we do as bridge builders. And what we've been dealing with for a long time is concrete quality and all the admixtures that go into it and what's changed, and dealing with old tests. And I think today he's going to talk a little bit about the super air meter. If you haven't heard of that before, you need to just scroll down a little bit and check out his video and his webpage on super air meter, because I'm going to be really advocating for that in the state of Indiana, and see who I can talk to, beg, borrow, or steal to try and get a super air meter and try to get some tests done. So with that, Dr. Lay, take it away, man.
Hey, well, thanks
Tell
so
us
much.
about it.
Super air meter is just a new way to really look at the air void system inside of concrete. We've been using volume for forever, right? And volume is great, and it's done a lot of good for some time, but our concretes today are so much more complex. Our admixtures are so much more complex. What we do to our concrete, we pump it, we consolidate it, we vibrate it, just so much more complicated. And we need to have a better understanding of that. And that's what the super air meter gives you. It gives you some idea about the bubble size distribution, and that's more important than bubble volume. So we've been doing some really cool work where we look at pumping concrete, and it's been interesting because a lot of people know that as you pump concrete, sometimes you'll lose some air. And we found some insane stuff. We found that like the air that you lose, it'll come back, or at least the important air, the small bubbles, that they'll come back. It takes them some time, but they'll come back. And if you've ever filled up a glass of water and drinking it, but you left it like maybe overnight, and you saw it the next morning, you'll see there's like air bubbles all around the glass. How does that happen? Well, we actually pump our water from place to place. That's how we get it. When you open the spigot, you're like decreasing the pressure and it fills up. And you see some bubbles, but then there's more bubbles that are dissolved. They're in that water that are dissolved. And the super air meter has been critical to help us learn this, because we can actually see the air coming back, and we can prove to people this is real. And this is people that have been talking about this for a long time. They think this is happening, but we can really see it and see what's going on. Another thing we can see is that not all admixture combinations are the same. And you really got to understand your construction processes and your cement and your fly ash and how they all work together to affect your air void system. And the super air meter cuts right through and gives you that info. I think so. It's really powerful. I think it's helped to make much more consistent concrete, but also much more longer lasting, durable concrete. It measures what matters, and that's what's important to us.
Oh, absolutely. And that is one of the things that I'm so excited about is, you spend time either as a concrete pumper or as a contractor, and you're out there and you've got several hundred yards, 1,000 yards, and they're testing every load or every third load, and you're chasing a number.
Yeah.
But you don't know what that number means.
Right.
And the super air meter comes along and it's like an aha moment. And you've got the empirical data to back it up. And I'm going to tell everybody, you've got to go check it out. It's amazing. If you like anything about concrete, this is the guy you need to learn from. And when it comes to chasing that number around at the concrete pump, your QC's trying to adjust things. It becomes real inefficient. People are trying to track what's going on. You've got the ready mix supplier there testing their own, saying no, it's good, and then you've got the state agency or the local agency saying no, it's bad,
right,
or vice versa. They're chasing it around, and what are they doing? They're adding more admixture to change it. And with the super air meter, I guess what I really like about it is the long-term testing that you've done, and where you really look at the concrete and what's important about why the air's in there and the durability of that concrete, and that's what we're trying to do. So we're not chasing this 6 to 8% air because we think that's what it should be, but we have to get away from that mentality. And like you said in your video, if you can take that super air meter or the SAM number, you can correlate that with your favorite mix. If you've got a Class C mix from a supplier that you like, and they don't change much of anything, every once in a while you run a super air meter, you can then correlate that with a plain air meter. If you don't have a lot of SAMs around, you can make it work.
Yeah,
you can make it work. But eventually, you're right. I want to see these super air meters everywhere, because I think they are a much more reliable test, and they're approved.
They are.
This isn't voodoo. This is an actual test method that's approved, and I think we just need to get a lot of people on board. And Federal Highway is already on board. So we just need to contact our local state agencies, our DOTs, and we need to talk to them. We need to advocate this.
That's right. No, I agree. I totally agree. Anytime you can measure what really matters,
yes,
you're going to be so much better ahead. You're not chasing some indirect thing. What really matters, that bubble spacing. And some concretes, you'll need actually a lot less air than what we use now. And some concretes, you may need a little bit more. And what you need to look at is that mix design. Because there's reasons. And we've never had ways to really probe and dive in and understand why one thing is good and one thing's bad, but now we have a brand new tool.
Yeah, and that's kind of where your research is heading now. Now we've got the basis down of what's now. Let's change things.
Exactly.
And it's really great because I'm betting, and I don't know if you've published anything yet, but I'm betting that you probably got some really good data on some cool admixtures out there for plasticizers and how that affects what's going on, and you've probably got a pretty good handle on where that needs to be, and that'll be exciting to learn in the coming years.
No, it'll be great. And one thing we're doing is we're working a protocol so that you can do a combination, certain combination, and you can see where you're at on this new chart. And you can see if you're in the good zone or if you're in the bad zone. And then you can tweak a variable and you can see where it moves you. You know what I mean? And you want to keep moving people to the good, because it's not going to be one thing. It's going to be, a combination of things. It's going to be look at mix time, look at whatever variable you want to move you towards that good zone. And that's just better, more stable concrete, more stable air void systems. And that's the key. That's the goal. Then it just makes everyone's life easier. You know what I mean?
Oh, yeah.
Hey, awesome.
Dr. Lay,
thank you so much.
I've been wanting to meet you forever, and go check out his work. It's amazing. It's too big of a body of work to ignore. Just some really neat stuff. So coming from ACPA, thank you, Dr. Lay. Awesome.
Thank you so much.